In this chapter, chapter 2.3, we're going to learn how to create stem and leaf plots and other types of graphs like dot plots and time series plots. So please review pages 68 through 74. Again, our objectives are to construct stem and leaf plots, to construct dot plots, and finally to construct time series plots. The purpose of creating stem and leaf plots is to sort the data quickly into a histogram and see its distribution type. So the process is, first find the smallest and largest value in the data set. Review the first digit of each individual values of the data and determine the stem set of values. Here is our stems. Draw a vertical line and place the stems in numerical order on the left side of the lines. For each observation, place the last digit in the row of the stem of the value of the individual observation. Place a comma for each next value. So our leaves are over on this side. So in the following data set, the ages of an extended family, we put it into a stem and leaf plot. And so we can see that the first ages, 7 and 9, are at the very beginning. And at the end there is a family members that are 75 and 77. The majority of the ages for this family are right here, between the ages of 10 and 16. So when we want to compare two data sets, we typically use a side-by-side stem and leaf plot. And so in the example that we're going to show you, there are two examples of grades, one in an English class and one in a history class. The process is basically the same. We will review the data sets to determine the stem values in each of the classes. We will place the stem values in order in the center of the diagram. So in this case, the center is here, and we will place the stem values there. We'll put two lines on either side. We have the history class on the left-hand side and the English class on the right-hand side. And then we put the leaf values for each observation on the corresponding row of that stem. And then we interpret the results. So in the case of the history class, we can see the values going from 59 on up to 100, whereas in the English class, it's going from 45 to 91. So here's our distribution for the history class. Here it is for the English class. And what can we determine? Well, certainly we can determine where the centers basically are. For the English class, it's around the 70 mark. For the history class, it looks like it's around 80. And so from that standpoint, we can see that the scores generally are higher in history than they are in the English class. So dot plots are used to show the distribution of the data set by frequency of values. It is used to give a rough impression of the shape of the distribution, but the limitations are calculations really cannot be made from this graph, whereas in histograms you can find the center and spread measures relatively easy. We will show that in Chapter 3. So the example we have is consider the number of children had by each U.S. president and their wives. Here's the data set for that. And for each observation, we just place a dot to the corresponding value on the x-axis. Here, x is equal to the number of children. So here we can see again a distributional pattern, right? It looks like 15 is the largest value. One of the presidents had 15 children. Not sure which one that was. But you can see that the majority of the presidents had 2 children when they were president of the United States. Our final graph in this section is time series plots. These are 2 variable quantitative variables that are being graphed. We call it bivariate data, and we'll discuss more of this topic in Chapter 4. Time series data are interesting because the x variable is always time. For time series, x is always considered time. The y variable is the related quantitative variable. So the example that we're showing you is a financial data set, and most data sets that are time dependent that we have in most magazines and newspapers are financial data. The following data set provides the average Dow Jones Industrial Average, Dow 30, from 2000 to 2012. Again, the x variable is the years here. It goes from 2000 to 2012. And then our y value is the average of the Dow Jones, right? So there's y, and there's x over here. You will notice that we put a dot for each value of the average within the diagram that meets the ordered pair. So for example, in 2000, the average was 10,786.85, and so we put a point as close as we can that represents that ordered pair on the graph. And we will do that throughout the rest of the graph. And then we connect the graph with lines. Some plots we will see in Chapter 4, we will not do that, and we'll have the computer generate kind of a linear line instead. So that concludes our chapter section 2-3, and we will be starting chapter 3 next time.